In this lesson, we're going to look at how to explain why lines are perpendicular this time, why they intersect at 90-degree angles, and also some problems we can solve knowing that that lines are perpendicular to each other. Um, Before we get into that, I have a couple of warm-up problems. Take a minute to attempt to solve them, and I will show you my solutions in a couple of minutes. Okay, what is the exact distance between these 2 points? Exact, meaning I have no decimals. And more to the point, either whole numbers or a whole number times a square root. So how do you find the distance between 2 points? Well, we have a formula for that. It's called the distance formula. We saw that in our first unit, the distance formula. That's the square root of subtract the x's and square it, and subtract the y's and square it. Another way of thinking of this is Pythagorean theorem. If you were to sketch these points and make a right triangle of it, you're going to find these x2 minus x1 and y2 minus y1 are the sides of the right triangle. In any event, let's plug some stuff in. How about I'll call this the first point, and this will be the second one. So that tells me that in this case, x2 is the second x, that's 5, minus x1, which is 2, and I'll square it. Y2 is 7, that's the second y. The first y was 3, and I'll square it. How do I simplify this? Let's see, I'm going to work inside out through using my order of operations, parentheses, exponents, multiply, divide, add, and subtract. I'm thinking of under the square root as like being a big parenthesis, so I'm going to look inside there first, and I'm going to see if there are any other parentheses. And I do still see more parentheses in each of these groups. So I'm going to simplify these things first. 5 minus 2 is 3. Square it. 7 minus 3 is 4. And I square it. Exponent, I can't do anything more in the parentheses now, so I'm going to do exponents. 9 plus 16. This square root is like a big set of parentheses, so I need to simplify what's inside of it first. Moreover, square roots, simplifying square roots, you cannot break up square roots over addition or subtraction. Square root of 9 plus the square root of 16 is emphatically not the same as the square root of 9 plus 16. You can quickly check that because 9 plus 16 is 25, and the square root of 25 is in fact the whole number 5. The exact distance is 5. If you did try to do these separately, you'd get 3 plus 4, which is 7. And 7 is not equal to 5. One of these two is wrong. It was this one. We do not do that. All right, also, let's find the value of x that makes these lines parallel. Let's see, it looks like I have an angle, some x squared plus 34x here, and I have negative 3x down here. These two angles are making a C pattern. These are consecutive interior. A consecutive interior should be supplementary, meaning they should add up to 180. So if these lines are going to be parallel, then x squared plus 34x plus negative 3x is equal to 180. Again, this is an x squared and an x in it. Our first strategy you should consider is to try to factor. And in fact, unless otherwise stated, factoring is going to be something you can use in almost every quadratic problem in this course intentionally so that you can practice that skill. So I can combine these things together, and if I'm going to factor, I need to get one side equal to 0. So I think this is x squared plus 31x minus 180. It should be equal to 0. The leading coefficient is 1, so I just need to find a pair of numbers that multiplies to 180, negative 180, excuse me, and adds to 31. They multiply to negative, so one's positive, one's negative, so I'm really thinking of subtract to be 31. What are some numbers that multiply to 180? I don't really know my multiples of 180 all that well, so I'm gonna try to. I'm gonna just do some. I'm gonna do some guess and checking. I'm gonna try to do this in a very intentional and hopefully smart way. And to do that, I'm going to actually make I'm going to write down some pairs of factors and multiply 180. I definitely know that 180 and 1 is a pair that multiplies to be 180. That's fine, but when you subtract them, they're nowhere near 31. Maybe some numbers are closer together. I know this number ends in 0, so like 10 and 18 have to multiply to be 180. In fact, they do. Can you subtract them to get 31? Well, no, they're too close. I want to generate other pairs of numbers that still multiply 180 that I can maybe add and get closer to 31. Here's a trick. If you know one pair of numbers that multiplies to something, and you want to get a new pair that multiplies that same number, I'm going to find a number that divides into one of these two numbers evenly. Like 10 is even, so 2 goes into 10. So what I'm going to do is I'm going to divide one of them by that number that goes into it. I'm going to divide 10 by, in this case, 2 to get 5. And then what I divided by, I'm going to multiply the other one by. So I'm like dividing one and multiplying the other by the same number. 18 times 2 is 36. Can you subtract this pair? This pair of numbers, 5 and 36, multiply to 180. Do they subtract to be 31? Oh, in fact they do. 36 minus 5 is 31. Bingo. Here's my pair of numbers that works. If that didn't work, you could try again. You could maybe divide this by 5 and multiply that by 5. Or go back to maybe flip the other side. Maybe divide 18 by 2 and multiply 10 by 2 and get more pairs of numbers that way. And and keep going until you find the pair that works. In this case, I know that 36 and 5 is my pair that works. And since they add up to be positive, I know the bigger one is positive. So what are my two possible values of x? I think x is either negative 36 or x is 5. Which one of these values, which one or both of these values makes sense in this diagram? Well, let's see. It's tempting to throw out negative 36 because it's negative, but in this case, this angle is equal to negative 3x. So when I plug in a number in for x, I can't have a negative angle. So if I plug in a negative in for x, negative 3 times negative 36 will be a positive value. In fact, it's positive, I believe, 108. That is perfectly fine. If I plug in positive 5, I get negative 3 times 5, which is negative 15, which is not okay. So I think x equals negative 36 is my winner. Okay, let's continue on here. Find the distance from point A to line BD. Distance is always measured at right angles. Because a right angle from a point up, measuring at a right angle is the shortest distance. Meaning, if you weren't doing that, then you could like lay your ruler down along from point A down here to point B, and that would be, and that would give you a length, but like that doesn't feel like the distance of this point is away. The distance is always the shortest distance, and shortest distance is measured at right angles. So in this diagram, what is the distance from point A to this line? It's the length from point A to this point, point D, that's at a right angle to it. So that's the length of point A from AD. And what do you know? Hey, this is, if I have 2 points, I can find the length of this segment using the distance formula. So I think the length of AD should be the square root of, just like in the warm-up, x2 minus x1, doesn't matter which one you call 2 and 1. I'll call A 0.1 and D 0.2. So x2 minus x1, negative 4 minus negative 1, and y2 minus y1. That is, let's see, the same as square root of negative 4 plus 1 squared, and 2 minus 8 squared, which is negative 3 squared plus negative 6 squared. If you type this into your calculator and you don't include the parentheses or you are careless and go too fast, you might think this is an error or you get a square root of a negative number. In fact, you don't, because this negative 3 squared is negative 3 times negative 3, which is positive 9. And negative 6 times negative 6 is positive 36, which is the square root of 45. This would be an acceptable answer. However, square roots, you should always try to simplify to the best of your ability. And simplifying the square root of 45, I could use a factor tree. 9 goes into it 5 times, and 9 is 3 times 3. Pair of 3s, escape outside. Single 5 stays under the square root. Square root of 45 is the same as 3 square roots of 5.